Welcome to all the students of BSc third year class. Hoping that you should get a good marks in the second year physics papers. In second year, we learn something about statistical mechanics, optics, electrodynamic, uh, and others. In this year, we'll learn uh, about modern physics in all papers. Uh, in first year, you have studied in same first year. You have got two semester, out of which in first semester you have learned two paper first and paper second. In second semester you learn paper third and paper fourth, and we have got one additional paper of practical. In second year we have sem 3 and sem 4. In sem 3 you have learned paper 6 and paper 7, and for sem uh, 8 and 9, 10 and 11 are the practical papers. All these things you have learned in the previous standard. In this year, third year, we have got therefore the paper number 12 onwards. In third year, we have got two again semesters, semester 5 and semester 6. In semester uh, we have two papers, paper number 12 and paper number 13, out of which paper number 12 that I can teach you in this semester. The title of the paper is the quantum mechanics. The syllabus of this paper is similar to the as pattern as earlier years papers. This in this uh, quantum mechanics paper we have got 4 unit. Each unit is having approximately the same weightage. First unit is the particle properties of waves, second Schrodinger's equation, third application of quantum mechanics, and fourth quantum theory of hydrogen atom. uh, Quantum mechanics is the one of the branch of the modern physics. Modern physics is divided into number of branches such as solid state physics, atomic physics, molecular physics, spectroscopy, quantum mechanics, statistical mechanics. All these uh, are the branches of uh, modern physics, in which quantum mechanics plays very important role. Since quantum mechanics is connected almost all branches of the modern physics. Quantum theory is applied on other branches also. Therefore, this quantum mechanics is very important. Therefore, we study some introductory concept in this paper, uh, which is useful in the development of quantum mechanics. The first unit having the title particle properties of waves. This unit will consist of the following points. First point is the introduction. In introduction, we should consider how quantum mechanics is developed. Then we have got photoelectric effect. Then we have got quantum theory of light. Then Crompton effect, de Broglie's waves. Then we have got some points of wave mechanics in this unit: wave function, de Broglie wave velocity, wave and group velocity, and the experiment, two experiment which supports The de Broglie's hypothesis, or one can say that the experimental proof of de Broglie's hypothesis can be done by these two experiments, G.P. Thompson's experiment and Davison-German's experiment. And last point of this unit is the uncertainty principle and its application. Most important, uh, as you know that in previous standard you have learned that the light is having the dual nature, that is wave-like as well as particle-like nature. In similar fashion, de Broglie thought that like light or radiation, matter in motion is associated with a dual nature, that is particle nature as well as wave nature, and such a thing is proved immediately by supporting the two experiments done independently. First, the Davison-Germer experiment and another G.P. Thompson's experiment. Both experiment supports support the de Broglie's hypothesis of matter wave. Therefore, the de Broglie's hypothesis of matter wave is also having the experimental proof. So all these things, all scientists are getting the Nobel Prize at that time. For photoelectric effect, Einstein will get the Nobel Prize. Uncertainty principle given by Heisenberg plays a very important role in the development of quantum mechanics. So that one can learn this principle, and by using this principle one can able to show that the electron cannot be exist inside the nucleus, but it is exist inside the atom. And some another applications of that, one more application we learn in this unit. The second unit of our syllabus is the Schrodinger's equation. Schrodinger's gives the two equation. First, the time independent equation and time dependent equation. This equation plays the very important role in quantum mechanics. In similar ways, the Newton's laws of motion and gravitation plays the important role in mechanics. So that Schrodinger's equation is the base of the, one can say that, the quantum mechanics, or it plays very important role in the development of quantum mechanics. In this unit we learn first introduction, then Schrodinger's equation, time dependent form, probability current. One can consider the flow of probability with time. Therefore, such a concept is termed as a probability